So this video follows on from the cluster assembly video. This one's basically showing how to take that assemble cluster and get you up and running with a full cluster. So there's a few sections in this one. We're going to look at how to install the heat sinks onto the board, make sure we've got them the right way around. Then we're going to look at the secondary board setup, so what we need to do with those, because those boards are easiest to set up outside the cluster because you need access to the Ethernet port. Then you'll need to set up the controller boards onto its Wi-Fi connection at that point as well. Then we're going to look at assembling all those boards into the cluster itself. Then we look at the rest of the controller board setup for once the boards are inside the cluster. And then once all that's running, then we look at the web front end setup as well, which is an optional piece to give you a bit more visibility and control over what's going on with the cluster. Okay, so now we're going to have a look at how to set up the Vim3s before we want to put them into the SBC cluster. So when the boards, when they come, they've got a couple of antennas on them. We've got the Bluetooth antenna here and the Wi-Fi one. For the board that we're going to use as the controller, we want to leave the Wi-Fi antenna on, but we can pull the Bluetooth antennas off for all of them. They just pop off quite easily. Wiggle the antenna, take that off, and then we can move the Wi-Fi one out of the way as well. So the next thing we want to put on are the heat sinks. So in the kit, so either the kit or the assembled version, you've got the small heat sinks to go on the processor, and also some adhesive to stick between the heatsink and the processor itself. So the first thing to do is just to clean the heatsink and the processor with a bit of alcohol if you've got it. So just give the base of the heatsink a quick rub off, and then let that over there to dry. Do the same thing with the processor. It's just because the give the adhesive the best chance of sticking. So then this is double-sided adhesive in here. So peel one side off, and be careful not to touch it. Then line that side up with the base of the heatsink, and then press it down. So this is pressure adhesive on here, so it's a good idea to give it a good squeeze, just to give it the best chance of sticking properly. So once that's on there, you can peel off the other side. This side's usually a bit more tricky to get off. So peel that off there, and then stick that onto the heatsink, onto the processor. So the important thing to remember is which way round these boards are going to be in the cluster. So effectively the boards are going to be stood up like that in the cluster, and the airflow goes from the front of the board here through to the back of the board. So make sure that the fins on the heatsink are the right way around, so that you've got good airflow going through the heatsink fins. Because that way around, there's some of the airflow gets blocked, whereas that way around you get much better airflow. So just line that up with the processor, and then again give that a squeeze down. You need to be reasonably careful because there's a number of components on the back of the board that you don't want to pull off, but still just give it a reasonably firm press. Okay, so that's the board now set up, ready to go into the cluster. Okay, so what we're going to look at now is how to set up the operating systems that need to go on the single board computers to let them work inside the cluster itself. They're relatively easy setup instructions, but there's just a bit of tweaking to do to make the Ethernet gadget mode work on all of the boards. So there's two sets of instructions here: the how to set up the controller, and how to set up the secondary ones. So we'll start with secondary ones because it's easiest to set up the controller and see it all working once you've got the secondary ones up and running. So the setup for the secondary controllers, as we'll see in a minute, assumes that we've already got an image burnt onto the single board computer. The image I'm using for this is the memory optimized Vim3 image. So that one's been specially set up to
with cryptocurrency mining in mind. So there's most devices are all disabled on it, so we've got no Wi-Fi, there's no HDMI, but what that results in is a really small kernel and also a relatively low power usage for the board as well. So all I've done for the Vim3 that we'll log into in a second is just burn that image to it, and there's some instructions down there on how to burn the image onto the eMMC. So that's just a link across to the Cardiff site that shows you how to do it. Okay, so we'll click into the secondary SBC setup instructions. So as I said a minute ago, these instructions all assume we've got the image burnt. So we'll just quickly scroll past that initial introduction piece. Basically what this first section does is set up the Ethernet gadget mode. So it's already enabled in the kernel, but we just need to do a little bit of initial configuration to set it up. We need to set some things up specific for each board, but I've put it together into a script file. So you can basically just copy and paste from these instructions straight into the board and get it up and running. So the first thing we'll do is we will log into the Vim3 that we're going to set up now. So I've not used this one before, so it'll ask me to confirm that I'm happy with it being authentic. And then after that, we just put in the password from Cardiff. So after that, it's a case of literally just following the instructions. So we can just copy and paste to do all of these instructions. So first up, we edit up a new file called usb.sh. So that'll be our script file that we're going to put the contents from here in. So we'll just copy all of the contents from here and paste that in. Now, in this script file, there's a couple of bits that you can change, and there's a couple of bits you have to change. So these here are the MAC addresses for the that are used on the USB gadget mode. So these have to be unique within the cluster. So what I've suggested here in the instructions is that you leave the first four octets all the same. We use this fifth one to identify which board it is in a multi-board cluster. So if we've got more than one SBC cluster board that we're joining together, then might want to look at having a different MAC address for those as well, just for ease of identification. That's not something we can do at the moment, but it's something I've got in the works. And then the last octet I've suggested we use to identify where it is in the cluster itself. So we'll set this one up as ready for slot 2. So literally just need to change both of those to 2, and then you save and exit that file. So Control X, press Y to say yes, and then enter to save it with that file name. So that's the USB script. So the next thing that we're going to do is make it executable by doing chmod +X. Now what we're going to do next is run it to make sure that it's worked. So if I just show you what, so those are the Ethernet devices or IP devices that we've got running at the moment. So once we've run that and the script works successfully, we'll also get USB 0 as a device in that list as well. So you need to run that script as sudo and put in the password, and then you don't get any output if it works, but when we go back into IPA, you can see that we've now got USB 0 has appeared down here at the bottom as a new device. So the last thing we need to do is copy that script into the root directory so that we can easily get it in the network interfaces file as the board's booting up. We need to set it so that script run every time the board starts, because that USB device doesn't persist when the board's rebooted. So So the last bit to do is, as it says here, is to move that script across. Try that again. Move that script into the root directory. Then we need to make it persist across. So we need to edit the network interfaces file with this command here. And then can just scroll down to the end of this file and just need to add in an entry for the USB device. So this one just sets it so that it uses DHCP, and before it brings that device up, it runs that script that we just put in, because obviously without running that script, we don't actually have that device. So once that's in, just Control X to save it, save it as the same file name, and then that is it. So the last thing to do is just test it to make sure that works. So just give it a quick reboot. Okay, so the board's finished rebooting now, so just reconnect to the board. Just log in again. And now if we use the IPA command, that USB 0 device is there. So it's there from the beginning. So that's that board sorted. So you can shut down that board now, and then just have to repeat all those steps again with the 3 other secondary boards, and then we can install all of the boards into the cluster itself.
So first thing to install is the three core I2C header cable that comes with the system. So first of all, plug one end into the 3-pin header down here, like that, and then the other end of this needs to plug into the controller board. So for a Vim3, the pin outs that you need is, so pin 21 is ground, pin 22 is the I2C clock, and pin 23 is the I2C data cable. So that means you need a bit of a twist over. So the pin out on the board is marked on the board, so it's marked as 0 for ground, D for data, and C for clock. So what that means is the pin out is slightly different round on the board to it is on the Vim3. So you just need to swap over the data and clock pins, clock wires. So then after that, that just simply plugs into the header on the Vim3. Like that. So that's the cables appropriately plugged into the Vim3, and then after that it's simply a case of plugging that into the system. So just make sure the cable folds over nicely, and then it's just the USB-C connector here just mates with the USB-C connector on the main board. So it's just a case of plugging that straight in. And that's how easy it is to install the boards into this system. So once you've got the first one in, then you can just carry on installing the rest of the boards. So again, simply for all the rest of the one, it's exactly the same. So USB-C connector just mates with the one that's on the board. Let's push those in. For these next ones, it's a little bit trickier because you have to try and put them underneath the cable. But again, simply just lines up with the USB-C sockets and is pushed down. Just carry on doing that for all the other boards. And then the last one in. and that's the SBC cluster board populated with the single board computers. So next step is to close all the case up, because you shouldn't power it up when it's open because you've got exposed mains wiring down here. So close the case back up, turn it back on, and then we should be ready to go. So now we're going to have a look at setting up the SBC controller board. So we'll just click through to the instructions. Now all these instructions assume we've got the Wi-Fi already set up, and we're going to be connecting over the Wi-Fi. So we can basically just skim past most of the initial sets of these instructions. We'll just scroll down to the networking setup piece. So we'll now log on to the Vim3 via its Wi-Fi connection. So I've got that set up there. So just log in. Just type in the password for it, and there we go. Then we're in. So you say the first thing to do is have a look at the networking setup, and we'll just have a look, and I'll show you that we've got a number of USB connections. So if you use the ifconfig command, you can see that we've got those 4 USB connections, which are the USB connections from the secondary boards that we've already set up. So you can see them all there available in the cluster. But what we need to do is get those so that they can all talk to each other and they can all get IP addresses. So what we need to do first is create a bridge, and then we can set up DHCP server after that. So the first, just clear that so that it's easier to see the instructions. So the first thing to do is make sure the bridge module is installed in the kernel. It is for the Vim3, so we can ignore this step for the Vim3. So the first piece here we need to do is add the bridge connection itself. So create the bridge interface. So that's that one created. And then after that, what we need to do is go through and add each of the USB connections that we just looked at to the bridge. So I'm just going to do those one by one. So that's the first one. Just added that one. And quickly do the second one. That's that one added. Get the third one. That's that one added. And then lastly get that fourth one in. And there we go, that's all of those bridge connections are, those slave connections are now added to the main bridge. So the next thing we need to do is set that bridge up so that it's got an IP address. So just I set it up with 10.0.0.250 as the IP address for the bridge. So that's a static IP address that we use for that bridge. So just add that. So that's gone in nicely. So now if we just use this, then we can show that the bridge is there and all set up and working. So just get that in. So there you can see the bridge connection is right at the top, BR0 device, with all those other the USB connections shown as slaves to that bridge, that overall bridge connection. So the other thing we can do with this as well is, because it's now got an IP address, we can ping that IP address as well. So let's just ping that to make sure that we can see that bridge connection there. And there we go, that we've got a response from the bridge connection as well. So we've actually got that set up and working. So just exit that. So that's the bridge all set up. So the next piece to do is the DHCP server. So just install the DHCP server itself. So this is what we're using to serve up the IP addresses to the individual secondary boards. So that's installed now. So now we just need to configure it. So there's a few steps to do here, but they're all just copy and paste, so all relatively straightforward. So just need to get into that initial configuration file. And we need to tell it in here which interfaces that we need the DHCP server to listen on. So this is where we just add in the BR0 device, so the bridge device that we just set up a minute ago. I'll add it for both IPv4 and V6, but we only ever use the V4 IP addresses in here really. So just exit that one with Control X, yes, and enter to save that one. And now we need to go and configure the DHCP scopes. So that's done in this config file here. So we just edit that one. Now the easiest way of doing this is just to comment out everything that's in the file already, and then it's easy just to paste the bits in at the end rather than individually going through and trying to work out which bits to replace. So just go through and comment out all of the lines that are in here already. A couple more down the bottom, I think. Yep, so that's it. So once we're at the bottom of the file, we can just copy in the correct config that we want to pull in from here. So we've got the range that we've got set up here, so going all the way from 1 up to 249, because 250 is what we set up as the DHCP server itself. So we're never going to use more than 4 anyway. So it's a bit of an overkill, but it's easy to set up. So that's the end of that file. So just exit out of that one. Now we've exited out of there, we can now restart the DHCP service just to get it to pick everything up. So that's that service gone, and now we can use this DHCP lease list command to show the leases that the DHCP server has given out. So at the moment there won't be anything to start with, but we should get one appearing. So there's the first one appearing. So just done a few more of those, but we can now log into that first one while we're waiting for the other boards to get picked up. So if we just log into 10.0.0.1, just accept that, and put in the password for the board, and there you go. That's us joined in to one of the secondary boards from the primary board over the USB networking connection. So that shows we're all good.
So now we've logged out of that one. If we have a look at the DHCP lease list. Yeah, so you can see that we've now got all 4 boards are now up and running with their IP addresses. So we will be able to SSH into any of those boards. So you can see all of that just really works. It's really good. So saves a lot of time on configuring. So that's all of those, the basic networking setup now. So the optional parts to put on the front of it is the web front end that we can use for a bit of monitoring and control of some of the functions. So now let's run through the setup instructions for the web front end. So again, this is pretty easy to set up. So first thing to grab is the software from my GitHub. So just clone that down. So the only other thing that's needed to get that working is the wiring pie, which you just follow the instructions here to install how to do that for the from the Carlos GitHub. So let's just change into the directory. So we need to be in the front end directory of that. And then the next thing we need to do is set up a virtual environment. So first thing to do is make sure that the virtual environment is installed already. Then we actually create the virtual environment that we're going to use here. So the system side packages allows us to pull in the wiring pie from the one that's installed on the Cardos GitHub. So once we've got that environment set up, then we can just activate it. Then we need to install a couple of things. So you need to install Wheel first. Otherwise, when we install the requirements for the web front end, then you'll get some failures on there. So that's Wheel installed. Now we can install the requirements that we need to run the web front end. So that's all good. And then it's simply a case of running the web front end after that. So just run that. So this is effectively running on a development server. So this is what I've been using at the moment. If you want to use it for production, you can use the WSGI server instead. So if you want to get it up and running permanently, I've just been using it for a test front end. So all we need to do now is basically put in the IP address for it. So this board is on 11. So you'll see that you start to get some connections coming through here. And so this is the basic front end. If I just make the screen a bit bigger. So basically you've got this home screen, and you've also got a firmware update screen. So this screen shows you what each of the slots is doing in terms of power consumption, and also gives you an opportunity to hard reset those slots as well. So you just literally just press that button, and that will give you a hard reset for the board that's in there. So if you look at the boards when you're doing it, then you can see that you get the LEDs will flash up and down. So that just literally powers the board on and off, which is useful if in something like the cryptocurrency mining applications, you can get to a point where the board's frozen up, or indeed any other reasons. That just allows you to reboot those boards really easily. And then the firmware update tab will allow you to just flash update into the firmware on the board. So there are no firmware updates to be put in at the moment, but when I've got some firmware updates coming out, then I'll run through how to do those. But it's literally a case of just choose the file and then press flash update, and off it goes. So that is the cluster board all set up. It's all up and running now. I hope you enjoy using it. If you've got any questions, then just join into the Discord channel, which the link to which is on the website. It's right down at the bottom of the website here. So there's a link here for logging in. So yeah, any questions, just come over there. Please ask.